students, this is third part in chapter alcohols, phenols and ethers. In our previous session we have studied the methods of preparation of alcohols. In today's session we shall study their physical and chemical properties. The first part is physical properties of alcohols. Physical properties of alcohols. You know, the general first property is always about their physical state. So alcohols are usually liquids. Up to carbon 11, those which contain up to 11 carbon atoms, they are liquids. They are liquids, and higher members are waxy solids, and higher members are waxy solids. Waxy solids means greasy solids. Then the second property, almost all alcohols, usually lower alcohols have characteristic alcoholic smell. You might be knowing the smell of alcohol. It is the same smell that you can imagine in a fruit of chiku. Chiku fruit also has the same smell of alcohol. So alcohols, especially lower alcohols, have characteristic alcoholic smell and burning taste. They have burning taste. Now what do you mean by burning taste? Whenever you drink, whenever you consume that alcohol, your throat gets irritated or will have a burning sensation. So lower alcohols have characteristic alcoholic smell with burning taste, and as the number of carbon atoms increases, they will have no smell or they are almost odorless. Then the third one. Third is about their boiling points. Alcohols boiling point is greater than their corresponding alkanes. If you compare an alkane with its corresponding alcohol, then alcohols will have higher boiling points when compared to alkanes. What is the reason behind higher boiling point of alcohols when compared to alkanes? This can be a 1 mark question. So you need to remember, an alkane cannot form hydrogen bond, whereas alcohols can form hydrogen bond, especially intermolecular hydrogen bond. Because of intermolecular hydrogen bonding, that is in this fashion, ROH, ROH. When two molecules join with each other by oxygen hydrogen bond, we call that as intermolecular hydrogen bond. Because of intermolecular hydrogen bonding formation, the boiling point of alcohols is higher than that of corresponding alkanes. Now what happens when the number of carbon atoms in the alkyl group increases? As the number of carbon atoms increases, as the chain length increases, as the alkyl group increases, boiling point decreases or increases. Boiling point increases. Now when number of carbon atoms increases, boiling point increases, and when the number of branches increases, if in this alkyl group, if the number of branches increases, then boiling point decreases. Alcohols have higher boiling point when compared to their corresponding alkanes. When number of carbon atoms increases, boiling point also increases, but if branching increases, boiling point decreases. The last point is their solubility. We all know that alcohols are soluble in water. You might have visualized this or seen in movies. They mix alcohol in water before consuming. So alcohols, especially lower alcohols, that is up to 3 carbon atoms, up to 3 carbon containing alcohols, they are soluble in water completely. As the number of carbon atoms increases, when the alkyl chain length increases, solubility decreases. Larger the proportion of alkyl group or the number of carbon atoms in a chain, lesser is the solubility of that compound in water. So lower alcohols, especially up to 3 carbon atoms, they are soluble in water completely because of the formation of intermolecular hydrogen bond. This time, once if it is an alcohol, the second time it is water, the next time again it is with an alcohol. So because of this intermolecular hydrogen bond formation with water molecules, alcohols are soluble in water. They are soluble in water. Which alcohols? Only lower alcohols. higher alcohols means those which contain greater proportion of alkyl group, they are insoluble in water because they do not form hydrogen bonding with water. Now this was about their physical properties. Now let us study chemical properties. Chemical properties form an essential part of this chapter because it is also important for almost all competitive exams. You can expect many questions from this part. So pay attention during chemical properties of alcohols. The first chemical property is reactions involving OH bond cleavage. What do you mean by cleavage? Cleavage refers to breaking. So if ROH is an alcohol, then we are now concerned about only breaking of this bond, OH bond. So reactions involving OH bond cleavage. The first property is their acidic nature, whether alcohols are acidic in nature or not. How to identify whether they are acidic in nature? So you have studied in your first year some concepts about acids and bases like Lux concept or Bronsted, Arrhenius concept, etc. So according to Bronsted concept, we know an acid is the one which donates a proton. So they are called Bronsted acids. Now whether alcohols donate a proton or not. So whenever an alcohol is dissociated, it produces alkoxide ion and gives away H plus in the form of a proton. So anything which donates a proton can be called as a Bronsted acid. So now you know alcohols are Bronsted acids. They are acidic in nature. They are acids because they donate proton. Because they donate proton, they are called Bronsted acids. Now if they are acidic, how do you prove? Let us see one reaction. If alcohol is reacted with anything which is basic in nature, especially alkali metals like sodium, this is the best known reaction. When these two react, it forms a salt, sodium alkoxide liberating hydrogen gas. Now for this reaction to happen, balance in this form. When alcohols react with sodium metal, it forms sodium alkoxide by liberating hydrogen gas. Liberation of hydrogen gas is an indication that each molecule of alcohol has given one hydrogen in the form of a proton. Two such hydrogens have combined to form hydrogen gas. Now the other proof is, to prove that alcohol is acidic, if this alcohol is reacting with a metal, this metal is especially alkali metal. Alkali is the other name for base. So if something is reacting with a base, this means that something, that alcohol is an acid. So acids and bases react with each other to form salt along with liberation of hydrogen gas. This is one reaction. Another reaction is, say you have alcohol, that is ethanol. If it is reacting with calcium, calcium is alkaline earth metal. It is from second group element. So when calcium reacts with ethanol, you will see that it also forms a salt along with liberation of hydrogen gas. These two reactions are sufficient to show that alcohols are acidic in nature. Just because they are acidic in nature, they are reacting with basic metals or alkali metals or alkaline metals and they are forming salts. If they were not acidic, they wouldn't have reacted. Then the second is, under this same acidic nature, to prove how they are acidic in nature or what happens to their acidic strength, we shall see. Now if this is the general formula of an alcohol, if I replace this R by CH3, CH3 we know, according to inductive effect, it is an electron donating group. Methyl group is an electron donating group. So all electron donating group, they donate their own electrons to the group or the atom attached to them. So this methyl group donates electrons to the oxygen. As a result, As a result, the electron density on oxygen increases. Now you may say, how does it increase? I'll enlarge this. CH3OH. This was methanol. Consider this as example to show the effect of electron donating group. Now methyl group is an electron donating group. If it donates electrons to oxygen, oxygen already has 2 pairs of electrons on it, so it has got surplus of electrons. Other than this group, when it was only ROH, we say this bond is a polar bond. OH bond is polar bond. Because it is polar, you can separate hydrogen easily. If the bond was non-polar, you wouldn't be able to break the bond between O and H. You cannot break the bond between oxygen and hydrogen if it were non-polar. Because it is polar, you are able to break. Now, if this bond is polar, it is polar by virtue of formation of bond between oxygen and hydrogen. If methyl group is donating electrons to the oxygen, it already has 4 electrons. Now methyl group is also donating its own electrons. Then the electron density on oxygen, it increases. If the electron density on oxygen increases, the polarity between oxygen and hydrogen gets disturbed. It gets disturbed. As a result, the bond between oxygen and hydrogen cannot be broken easily. When can it break easily? If oxygen and hydrogen share the same degree of polarity. If any one of the atoms have increased electron density, then the polarity of such a bond decreases or it gets disturbed. When polarity gets disturbed, this bond cannot be broken. As a result, acid strength decreases. Alcohols are acidic in nature. To prove that they are acidic in nature, you saw 2 reactions with metals. Now to say how much acidic they are, we can say relative acidity of alcohols. How much they are acidic, you can say that alcohols are acidic by virtue of OH bond, which is polar. If an electron donating group, which is always present in alcohols because of this general formula R, if an electron donating group is attached to OH bond, then all alkyl groups, by virtue of their positive inductive effect, they act as electron donating groups. Since they act as electron donating groups, they donate electrons to the oxygen hydrogen bond. When they donate electrons, it increases the electron density on oxygen atom, which disturbs the polarity of OH bond, making the bond difficult to break. Since the bond cannot be broken, since hydrogen cannot be separated, since hydrogen cannot go alone as H plus or as a proton, so acid strength decreases. When is the acid strength more? When a compound is able to separate H from itself. Now when H cannot be separated, when hydrogen cannot go as a proton, you cannot call it as a Bronsted acid. Therefore, alcohols are acidic in nature. They are acidic in nature by virtue of OH bond, by virtue of its polarity. If an electron donating group is attached to the OH bond, then the electron density on oxygen increases, therefore acidic strength decreases. Now if this part is clear, let us compare 3 different alcohols. Say this is one alcohol, this is one alcohol, this is another alcohol, and this is one more alcohol. All the 3 are alcohols. Now let us guess which one is more acidic, most acidic. I label this as 1, 2 and 3. I said that if OH bond is polar, then acidic strength increases. If somehow electrons are pumped onto the oxygen, then the acid strength of such compound decreases. Now in this case, this group donates electrons to oxygen, so its acid strength is less. In this case, to this carbon from here, again from here, from here, and in this case 3 groups. So larger the alkyl group, more is the number of electrons pumped. Larger the alkyl group, more is the number of electrons pumped. So greater the number of electrons pumped, lesser is the acid strength. On that note, primary alcohols are more acidic than secondary alcohols, which are more acidic than tertiary alcohols. So which alcohol is most acidic? A primary alcohol is more acidic than secondary alcohol than tertiary alcohols. Then let us see the next set of reactions. This was general, whether they are acidic or not, or how relatively acidic they are. Under the same, let us see the second one, esterification. Esterification question is a hot favorite question of all the question paper setters. Whichever person sets the question paper, you will find that this forms an integral part of it. So do not neglect this part. It's an easier part. Mechanism is not there for your syllabus. So whenever alcohols react with carboxylic acid, this is esterification reaction equation. For the sake of convenience, I'll change this as, I'll write carboxylic acid at the beginning, followed by alcohol, ROH. When these two react, you eliminate water from this, H2O is gone. Whatever is left behind, you combine and write. So RCOOR. In order to differentiate, let us label one R with a prime. The product is called ester. For this reaction to take place, you need compulsorily concentrated H2SO4, without which the reaction will not proceed. Sir, what happens if I fail to write concentrated H2SO4? Then this reaction will become reversible. Means whatever ester is formed, it will hydrolyze in water and again forms alcohol as well as carboxylic acid. To avoid the reversibility of this reaction, you are supposed to use compulsorily concentrated sulfuric acid. So how do you give the statement of this reaction? When carboxylic acids react with alcohols, or when alcohols react with carboxylic acids in the presence of concentrated sulfuric acid as a dehydrating agent. Its role here is a dehydrating agent. When carboxylic acids or alcohols react with each other in the presence of a dehydrating agent like concentrated sulfuric acid, you get esters along with the liberation of water molecule. This reaction is called as esterification reaction. Simple. There are other ways of representing esterification reactions. Sometimes you can take acid anhydrides. They too react with alcohols under the same way. The only difference is here you are supposed to use pyridine. Again same, the product is RCOOR plus RCOOH. So you will get this time an ester and a carboxylic acid. Or else if you have acid chlorides, if it is reacting with alcohols in the presence of same pyridine and not concentrated sulfuric acid, then also you will get RCOOR dash, that is an ester plus HCl. So all the three are esterification reactions only. Most prominently they ask the first one of alcohol and carboxylic acid. If this is given and you are asked to identify the reaction, do not get confused, it is also esterification reaction. So what is esterification reaction? Whenever alcohols react with carboxylic acid or acid anhydrides or acid chlorides, then esters are formed. If you are using carboxylic acid as one of the reactant, then use dehydrating agent like concentrated sulfuric acid. Some others are also there like anhydrous ZnCl2 or Al2O3 etc. or H3PO4 phosphoric acid, they too can be used. Simply to avoid confusion, if you are able to remember those three also fine, if not, concentrated sulfuric acid is the best dehydrating agent. This is to be used only when you are using carboxylic acid as one of the reactant. If the reactant is acid anhydride or acid chloride, then use pyridine, or pyridine, whichever way you pronounce. So this is esterification, an important question for exam point of view. So what is esterification? Whenever carboxylic acids or acid anhydrides or acid chlorides react with alcohols, esters are formed. This reaction is called esterification. Now let us see the second set of reactions. Reactions involving CO bond cleavage. Where does the bond break this time? If this is an alcohol, commonly example CH3OH, then this time the bond breaks here between carbon and oxygen. So let us see the first set of reactions in this. Reaction with hydrogen halide. You should have studied this reaction even in the first organic chapter, haloalkanes and haloarenes. Whenever alcohols react with hydrogen halide, this part gets separated. The product formed is alkyl halide and water. The product formed is alkyl halide and water. To give a more specific example, if the same ROH is written, instead of HX, if you are using HCl, the product is RCl plus H2O. For this reaction to take place, you need anhydrous ZnCl2. A mixture of these two is called Lucas reagent. A mixture of hydrochloric acid and anhydrous zinc chloride is called Lucas reagent. Why this reaction is important? There can be a number of 1 mark questions from this part, like what is Lucas reagent? Concentrated HCl and anhydrous zinc chloride is called Lucas reagent. What is it used for? This Lucas reagent is used in order to distinguish among primary, secondary and tertiary alcohols. How are these three alcohols identified? By using Lucas reagent. So keeping this as intact, always changing this alcohol, you can be able to identify them. When a given alcohol is reacted with Lucas reagent and upon shaking, if any turbidity or cloudiness, muddiness appears in the solution immediately, then it is tertiary. For tertiary you will have immediate turbidity. For secondary alcohols you have turbidity in 5 to 10 minutes. For primary the solution remains clear or no turbidity appears at room temperature. So how are the three different alcohols identified? They are identified by Lucas reagent. What is Lucas reagent? Concentrated HCl and anhydrous zinc chloride. How is it used? It is mixed with a given alcohol. If it gives immediate turbidity or cloudiness or muddiness, then it is tertiary alcohol. If it appears after 5 to 10 minutes, then it is secondary. If no turbidity appears and the solution remains clear even at the room temperature, then it is primary. So utilizing this, you can say which alcohol reacts faster with a given hydrogen halide. So the alcohol which reacts very fast with a given hydrogen halide is tertiary. So the order of reactivity of alcohols with HX is tertiary alcohols react faster than secondary than primary with hydrogen halide. Then the second is reaction of alcohols with phosphorus halides, especially PX3. So a given alcohol reacts with phosphorus trihalide. Then what product is formed? The same product, alkyl halide along with phosphorus acid. Phosphorus acid. If the same alcohol is replaced by methanol and PCl3, then the product should be methyl chloride and phosphorus acid. What does this reaction indicate? It also indicates that the bond gets broken here and not with OH. So these two reactions show that alcohols can be broken not only between O and H, they can also be broken between carbon and oxygen. Let us see the third set of reaction. It is dehydration. Dehydration of alcohol is a very important question for exam for 3 marks. Without this, there is no question paper at all. So it is one of the fixed questions in annual exam paper, dehydration of alcohols. So how is this done? Whenever ethanol, I shall take directly the main example that is asked in exam. So whenever ethanol is dehydrated, dehydration refers to removal of water. So if you want to remove water from alcohol, utilize any dehydrating agent like concentrated H2SO4. Simply said, an acid. So the product should be an alkene along with water. Whenever alcohols are heated in the presence of a dehydrating agent like concentrated sulfuric acid, alkenes are formed. This forms the general statement for dehydration. Let us see the mechanism now. The mechanism for dehydration involves 3 steps. In the first step, this alcohol takes up a proton. You may ask, sir, where did this proton come from? It came from the acid and becomes protonated alcohol, One H was already present, this H got attached here. So it has now become protonated alcohol. The second step says remove the protonated part. So if this part is removed, what will be left? You will have water, H2O will go, the same positive charge will be transferred here. So CH3, CH2 plus. Ethyl carbocation is formed. And now how is this ethyl carbocation and our product alkene differing? They are differing only by a proton. So the third and the last step should be loss of proton, that is ethyl carbocation is subjected to deprotonation, which gives CH2 double bond CH2 plus H plus. This H plus can again go and combine with other elements to other part to form sulfuric acid. This can be split as CH3 dash CH2 plus. Okay. So one bond shifts here, the hydrogen along with H plus goes away. So what is left? CH2, this bond shifted here, therefore it became a double bond. So dehydration of alcohols into alkenes is a fixed question. Please do not neglect this part. Whenever an alcohol, especially ethanol, is dehydrated in the presence of sulfuric acid as a dehydrating agent, then you will get alkenes. Which alkene? Ethene. They will be asking you to explain the mechanism of acid catalyzed dehydration of ethanol. So how is it done? In the first step, ethanol takes up a proton to become protonated alcohol. In the second step, the protonated alcohol loses water molecule and becomes ethyl carbocation. This ethyl carbocation is 1 proton extra to form alcohol, therefore deprotonation is done. In the third step, deprotonation takes place to give you alkene. Which alkene? Ethene. So then the fourth part is, or a fourth set of reaction is oxidation. An alcohol upon oxidation, an alcohol upon oxidation will give you, it will give you an aldehyde. It will give you an aldehyde. Oxidation is nothing but addition of oxygen. So after an aldehyde is formed, it can be further oxidized to give you carboxylic acid. So what is the final product whenever alcohols are oxidized? Alcohols upon oxidation will give you final product as carboxylic acid. But remember, the oxidizing agents that can be used for oxidation are acidified potassium dichromate or alkaline potassium permanganate. You can use either acidified potassium dichromate or alkaline potassium permanganate. There are others also, like dilute nitric acid can also be used as an oxidizing agent. If any of these reagents are used, an alcohol gets oxidized to give you carboxylic acid. Now if your intention is to stop the reaction at aldehyde only, you do not want this reaction to proceed till carboxylic acid. I mean to say, if you want to have this reaction stop at only aldehyde and it should not proceed further, then you cannot use any of these. These three oxidize alcohol completely to give you carboxylic acid. If you want the oxidation to be partial, for partial oxidation you are supposed to use this reagent. It is called pyridinium chlorochromate. Pyridinium chlorochromate, or else you can use chromium oxide in any acidic medium. Chromium oxide in acidic medium. Now you have studied reaction with hydrogen halide, reaction with phosphorus halide, and then you studied dehydration followed by oxidation. There is one more point to be remembered. A primary alcohol upon oxidation will give you an aldehyde, which upon oxidation will give you carboxylic acid. A secondary alcohol upon oxidation will give you ketone. It will give you ketone, which will give you carboxylic acid. Again, how is it different? Primary alcohol upon oxidation will give you aldehyde, which will give you carboxylic acid. A secondary alcohol upon oxidation will give you ketone, which gives you carboxylic acid. Tertiary alcohols are generally resistant to oxidation. They do not easily undergo oxidation. Now for them to be oxidized, if you want a tertiary alcohol also to be oxidized, then you need any strong reducing agents like these. And moreover, the product carboxylic acid formed will be containing lesser number of carbon atoms when compared to the parent alcohol that you have used. Say if you are using a 5 carbon containing alcohol, a 5 carbon containing tertiary alcohol for oxidation, no doubt you will get carboxylic acid, but that carboxylic acid will contain lesser number of carbon atoms than the alcohol. You used 5 carbon atoms, so your product carboxylic acid will not contain 5 carbon atoms, it will contain less than 5 carbon atoms in it. So how do you remember this? Primary alcohols on oxidation will give you carboxylic acid, secondary alcohols on oxidation will give you carboxylic acid, tertiary alcohols are resistant, still they will give you carboxylic acid. The only difference is tertiary alcohols are resistant, they can be oxidized by using strong oxidizing agents, but their oxidation will give you product carboxylic acid containing lesser number of carbon atoms compared to the parent alcohol that you used. Primary alcohols on oxidation, first they will give you aldehydes followed by carboxylic acid. Secondary alcohols on oxidation will give you ketones, which proceeds to give you carboxylic acid. Tertiary alcohols are resistant to oxidation. If you want the reaction to stop at midway, if you want partial oxidation, then which oxidizing agent can be used? Either PCC, pyridinium chlorochromate, or chromic oxide in acidic medium. The next and the last set of reaction is dehydrogenation. It is dehydrogenation. More accurately, catalytic dehydrogenation. Catalytic dehydrogenation. Till now we have studied dehydration. Dehydration refers to loss of water or removal of water. So dehydrogenation should be removal of hydrogen. So if an alcohol is used for dehydrogenation in the presence of copper as a catalyst at 300 degrees Celsius, then remove this part. What is left? It is an aldehyde. Simple. For alcohols to undergo dehydrogenation, you need copper catalyst at a temperature of around 300 degrees Celsius. So if you use a secondary alcohol, for dehydrogenation, then remove this part, you will end up with ketone. Now what happens if you use a tertiary alcohol? A tertiary alcohol, when it is dehydrogenated using same copper at 300 degrees Celsius, you will not get either aldehyde or ketone. Instead you will get alkene. You will get CH3 double bond CH2. Remove one hydrogen from here along with water plus water. Very interesting set of reactions are there in alcohols, which is why it forms an important place in many questions in many competitive exams. See, a primary alcohol gives you, upon dehydrogenation, aldehyde. A secondary alcohol gives you ketone. A tertiary alcohol will give you alkene. When it was oxidation, primary alcohols gave you aldehyde followed by carboxylic acid. Secondary alcohols gave you ketones followed by carboxylic acid. Tertiary alcohols were resistant to oxidation. Still they gave you carboxylic acid, which contained less number of carbon atoms. When it comes to dehydrogenation, primary alcohol gives you aldehyde, secondary alcohol gives you ketone, and tertiary alcohols do not give you any carbonyl compound, that is aldehyde or ketone. Instead they will give you alkenes along with the liberation of water. So these were the chemical properties of alcohols. In our next session we shall see some more parts and some more topics about phenols. This was all about alcohols. Thank you.